Equations with fractions. All right, well, here's an equation with fractions. 2/3 x minus 5/6 equals 1/2 x plus 1/12. There's an equation. It's got a whole bunch of fractions in it. Other than running away screaming, what would you do? What do you mean by their respective numbers?
You gotta get them all together.
All right, so what I do is I look at all the fractions all at the same time. There's 4 of them, and I find a common denominator that works for a 3, a 6, a 2, and a 12.
12.
A common denominator is 12. In fact, that happens to be the least common denominator. What I'm going to do is I'm going to take that common denominator of 12, and I'm going to multiply it by every single piece. And that's going to do a really, really nice thing for me. So we find the common denominator, we multiply by the common denominator. And here's why it's a really, really good thing. What's 12 times 2/3? What? 24/3, which is a fancy way of saying 8. 24 divided by 3 is 8, isn't it? So that's 8x. Minus, what's 12 times 5/6? It's 60/6, which is a nice way of saying 10, equals 12 times 1/2. So that one becomes 6x. And finally, 12 times 1/12. 1. So, why was multiplying by that common denominator a really, really nice thing? It made all the fractions go away. And so that's what you should do anytime you see an equation and your equation has fractions. Multiply it by the common denominator, get rid of the fractions. Makes your life a whole lot easier. All right, well, this is an easy one to solve right now, I hope. Move the 6x over. 2x equals, move the 10 over 11. Divide, x is 11/2. Once the fractions are gone, your life is pretty easy. Questions on that one?
You would rather leave that in fraction form rather than doing this?
I would accept fraction form for this problem. I would accept decimal form for this problem. Because this one, if you type it in, it's 5.5. I would avoid decimals if you have to round them off. So if this came out to be 11/3, I would prefer the exact rather than you giving it to me rounded off. Okay? So if you just leave it in fraction, then there's less steps you got to do anyway. So let's just leave it as a fraction. All right. Well, of course, they're not going to be all that great, I suppose. What if I had 3 minus x minus 2 over 5x equals 1/5? All right, so sometimes our equations are going to have fractions, but sometimes we're going to have x's on bottom too, not just numbers. What do? You still find the common denominator, which is 5x, and what are you going to do with that common denominator? Multiply by all of them. And all of them is a key thing. You got to think of 3 as 3 over 1. That's a fraction too. And that's the easy one to forget. A lot of people will forget to multiply by the 3 by 5x. But you got to multiply there too. So we multiply by 5x. We multiply by 5x. We multiply by 5x. We do it everywhere. Even if pieces are not fractions, you still multiply by the common denominator. 5x times 3. 15x. Minus. What happens when I take the 5x and the 5x and reduce them out? They get crossed out, and what am I left with? X minus 2. Depends on how you write it. And what I mean by that is, if you write that, you're wrong. No, the x should be negative.
But it's still, in and of itself, its own little fraction that needs to be defined.
Right. When you subtract something like this, you need to subtract the entire thing. So you should either write it that way, or you should distribute that minus through, which is what we're going to do in just a second anyway, and the 2 becomes positive. So watch out for that. That's, again, a very, very easy mistake to make. That's a spot where people always lose minus signs right there. Watch out for that. And this one over here becomes x. All right, so simplifying, 15 minus x, that's 14x. Minus a minus becomes a plus 2 equals x. And once again, at this point, it should be very simple. 13x equals negative 2. So x is negative 2 over 13. And again, I would greatly prefer the fraction form on this one. The decimal would be repeating decimal of some sort. I'd much rather leave it as a fraction. Questions on that one? When you have x on bottom, there is something you need to be careful of. Let me see if I can find a problem that will do what I want it to do. Let's try this one. And we'll talk about what we need to be careful of. 1 over x squared minus x equals 1 over x minus 1 plus 1 over x. All right, well, again, I see lots of fractions. I find a common denominator. What's my least common denominator? X squared minus x. Because x squared minus x factors as x times x minus 1. So you're right, x squared minus x is our common denominator, but I'm going to write it as x times x minus 1. That way it'll be easier for me to reduce things, I think. All right, so on the left-hand side, that and that completely wipe each other out. I'm left with 1 equals, over here, those go away, so that's an x, plus, over here, these go away, x minus 1. Good? Well, I got to add 1 to both sides, so 2x equals 2. So add 1 to both sides, 2 equals 2x. Divide both sides by 2, I get x equals 1. And you've done everything right, and you're really, really happy. And you leave your answer just like that, and then you get your paper back, and the teacher marked it wrong.
Because you got it wrong.
Yeah, what's wrong? You didn't do any work wrong. Every step we did is completely correct. Oh, it's okay if a number comes out to be a nice number like 1. We're happy with that usually. Sometimes the answers come out real nice. The x is on the wrong side? Nah, it doesn't really matter. Here's the problem. What happens if I try to take 1 and plug it back into the original equation? It doesn't work. Why not? Well, it's even worse. What happens when I plug 1 in right there? I get 1 minus 1, which is 0. I get 0 on bottom of a fraction. What happens when I have 0 on bottom of a fraction? It's undefined. My paper bursts into flames. Right. It's bad. So this can happen, and this is something you need to be very, very careful of. When your equation has x's on the bottom to begin with, when you get all done, you need to go back and check. You need to go back and plug this number in and make sure you do not get 0 on bottom anywhere. When I try to plug 1 in, I get 0 on bottom right there. It also happens that I get 0 on bottom right there. So you do all this work, you get an answer, x equals 1, but x can't be 1 because it gives you 0 on bottom. So what's the right answer? There is no correct solution. That's correct. So our final answer for this problem would be no solution.
That one on the far right with the 1 over x, and you cross out the x's. How did you go from that without doing x minus 1 on the bottom?
Well, I'm taking x times x minus 1. I can always multiply any equation by whatever I want. So I'm taking this whole equation, and I'm multiplying it by x times x minus 1. So I'm thinking of this as being over 1. So I have something on top that reduces with something on bottom. And then the only thing left is an x minus 1. Notice I'm not getting a common denominator. I'm not making it so that the fractions all have the same denominator. And that kind of sounds like what you were thinking maybe.
Yeah, that's what I'm stuck on.
Right. We're even back in this first problem. Notice I did not rewrite the fractions so that they all had 12 on bottom. Rather, I noticed 12 was my common denominator, so I multiply by that to clear the fractions. So it's different from what we did last time. Last time, in order to add and subtract fractions, we said we have to get a common denominator. We made the bottoms be the same, and then we added them. We're doing something similar here. We're finding the common denominator, but then we're multiplying the entire equation by that common denominator, and that wipes out the fractions for us. We'd much rather wipe out fractions than have to add and subtract them. At least I would rather wipe them out. Okay, so it's different from last time. We're not getting the common denominator on bottom. We're using the common denominator to get rid of the bottoms. Okay? All right, so when you go to take your test, though, you need to be careful on that. All right, so let me show you two problems that look very similar that you're going to do very different ways on your test. I might give you x over x minus 1 plus 5 over x. That might be one question. And then another question might be x over x minus 1 equals 5 over x. Oh, that's going to be a bad problem. I will talk about that second one in a minute, why that's a bad problem. But they look almost exactly the same, don't they? Ish. The only difference is this one has a plus, where that one has an equals. The plus means we want to add those fractions together. In order to add those fractions together, we have to have a common denominator. The second one, we can use the common denominator to clear the fractions and get rid of them. So you do these. These look kind of similar. They got the same fractions, but you do them in different ways. So this one, you're going to go like this. You're going to say the common denominator is x times x minus 1. So the first fraction had an x up on top to begin with. What new thing did I put on bottom? Another x. I need an x on top. The second fraction had a 5 on top to begin with, and the new thing on bottom is x minus 1. So that the answer to this one would be x squared plus 5x minus 5 over x times x minus 1. All right, as like I said, the second problem we're actually not going to be able to solve, and we'll see why in just a second. What would you do? So you find the common denominator, just like we did the first time. The common denominator is x times x minus 1. But what do you do with it? You multiply. So I'm going to multiply by x times x minus 1 to wipe out the fractions. But the only time you can do that is when you have an equation. If I do not have an equation to begin with, I can't wipe out the fractions. So that's the difference between the two of them. Yeah. Equations, you wipe them out. Right, that's the only time. Well, those go away, right? So I have x squared equals, and then these go away. I have 5x minus 5. The problem we have right now is this equation is not linear because it's got an x squared, and we don't know how to solve non-linear equations yet. It seems as though you would want to do a square root, but if you do a square root, you're still going to have an x over here. You're not going to have just a number. So yeah, it has something to do with square roots, definitely. But we don't know how to solve that equation yet. So I made up a bad example off the top of my head. But it has a lot to do with chapter 7. Oh yeah. So by the time we finish chapter 7, you will know multiple different ways to solve that equation. But right now we don't know how to do it. What's that? And it does involve square roots, absolutely. To get rid of a square, you're going to use some square roots, absolutely. But we don't know how to solve that equation yet. But that's the big difference that I wanted to point out. If you just start with an add, subtract, multiply, or divide problem, when you get done, you're going to have fractions. When you have an equation, you can wipe out the fractions and make your life easier. All right, so anyway, watch out for this. Quite often, as I say, you do all the work, and you get an answer, and your answer looks just wonderful. Make sure you go back and plug it in and make sure you do not get 0 on bottom. So I should do that with this other problem that we did. We got x equals negative 2/13. Does that give me 0 on bottom? No. So this answer is okay. Assuming I didn't make any mistakes, that answer is correct. But we know this one's wrong. We know x can't be 1. So watch out for that. That happens once in a while. When you try to solve, you do all the work right, you get an answer that just doesn't work. That's frustrating because you did all that stuff, all those steps, and then you cross it out and write no answer. Kind of bothers me to have to do that. But that's the way it goes. All right, let's try one more. And then I'll give some for you to try. How about 3 over 4x minus 6 plus a quarter equals 5 over 3 minus 2x. Four x minus 6 is the common denominator. I don't quite think so. Because if I multiply 1/4 by 4 times, if I take 1/4 and multiply it by 4x minus 6, I don't have a 4 on top and a 4 on bottom that I can cancel with. Because this 4 is going to be trapped with the minus 6 thing. So you're close. Close, but not quite correct. Well, I think what I would do, I think I would factor this denominator right here. How do you factor 4x minus 6? I can take a 2 out. So this is 3 over 2 times 2x minus 3 plus a quarter equals, this one bothers me. That one bothers me because it's written in the wrong order. It's got minus 2x, it's got 3 minus 2x. That's not how we usually write stuff. How do we usually write stuff? We put the variables first, and then we go by big exponents down to small exponents. Correct. So I could write it as negative 2x plus 3, but that bothers me too. Yeah, it does. I don't like having the first thing be negative. I like the first thing to be positive. So this, I can't always get, oh yes, I can. I'm the teacher. So this is the same as minus 2x plus 3 with a 5 on top. What I think I would do, what I'm going to do, I'm going to take this fraction and I'm going to multiply top and bottom by negative 1 to make this thing be positive in the first spot. So I'm going to rewrite this as negative 5 over 2x minus 3. And that does a good thing for me. Now I notice that this 2x minus 3 matches with that 2x minus 3. So I see that if I multiply by a 2x minus 3, those will both wipe out. So watch for that. That happens every now and then. Every now and then they write the bottoms backward. To fix them, multiply top and bottom by negative 1 to turn it around and get it the way it should be. All right, so now what's my common denominator? I definitely need a 2x minus 3.
Yeah.
What else do I need? A 2. What about that? A 4. So instead of a 2, I really need a 4, don't I? I could factor that as 2 times 2. So I need a 2 from this one, and I need 2 2s from this one, which means I really need a 4. 2 squared. I could write it as 2 squared. I could write it as 4 times 1. That's good. All right, so I'm going to multiply by 4 times 2x minus 3. 4 times 2x minus 3. 4 times 2x minus 3. On this one, the 2x minus 3 reduces with the 2x minus 3. The 4 also reduces with the 2, leaves a 2 over. So that's a 6. Plus, the 4 reduces with the 4. 2x minus 3 equals the 2x minus 3 goes with the 2x minus 3. So negative 20. All right. Once again, once the fractions are all gone, the problems should be relatively simple. I'm going to add 3 and subtract 6. So 2x is 20 plus, or negative 20 minus 6 is negative 26. Negative 26 plus 3 is negative 23. So divide, x is negative 23 over 2. Questions on that? I have a question. Is that the right answer?
Yes,
In fact, not only can I check, I darn well better check to make sure I don't get 0 on bottom.
you won't.
I won't, because looking at my bottoms here, what number would give me 0 on bottom? Not this one? Not that one is correct, but which number would give me 0 on bottom?
Oh, that's a weird number.
Some weird number? Well, if I wanted to have 0 on bottom, I'd have to add 6 and then divide by 4. So 6 over 4 sounds like 1.5, sounds like 3 halves. 3 halves would also give me 0 there. Is this number 3 halves? No. So this number is probably correct. Assuming I made no mistakes, it's okay. If I did all this work and I got x equals 3 halves, I would have to cross it out and say no good. So again, I don't really need, I mean, it wouldn't be a bad thing, really. It wouldn't be a bad thing to take this number in, take this number, plug it in on the left-hand side, plug it in on the right-hand side, and make sure it works. Kind of a pain in the neck when you're dealing with a fraction and then you got more fractions here. But you could. The biggest thing you do need to check for is make sure you're not dividing by 0. And we're not dividing by 0. So I'm pretty confident that answer is correct. Questions?